All right. I say, let's go ahead and get started. The recording can be there if they need to catch up, but I think otherwise, Oliver, take it away.
Here we go. You guys can see my screen?
Hey! There we are.
Okay. Yeah, so been asked, I think the third or fourth time. Well, I offered actually, I wasn't asked. I offered to present again at the Cribl UG group. Always happy to do so, as you guys know me. Actually, I'm just repeating what I used over the last couple of months personally while load testing certain solutions. Some of you might recall a talk I did for Splunk B-Sites a couple of months back, metric store. I load tested this exactly with that setup here. Makes always sense. So what will we do or will we be discussing today? We have a problem usually, right? Let's start with a problem statement. That's very German actually, isn't it? Germans always have problems. Well, we try to find solutions. Performance and load testing requires some difficult setups usually. All of us who have played around with stuff like whatever, Apache JMeter and stuff like this, it is quite annoying. And usually we don't need that depth of API calls, etc., because we're in the analytics setup or world, we are load testing usually our analytics solutions, or we need some sample data in a huge fashion or whatever. So it can be quite difficult just to simply set up a data sample and grow it to the size we need it. If we want to kill the destination or not is a different question. We will kill a destination today, hopefully. That can be obviously tricky, especially when it's getting big. I've seen people literally load testing by moving gigabyte files of logs on shelves into source folders, and that's just like, nope. That's not what you should be doing. Additionally, make it reproducible is a problem, right? We want to have reproducible setups because sometimes we compare different vendors, no names please, right? Different analytics vendors for their metric stores, for their log stores, for whatever. And yeah, should be comparable. Cool is as well, if you can run them in parallel, that's even better and not sequentially, right? The customization of the data samples, yeah, is required because of the latest point here as well. I've seen people load testing in public spaces like cloud, whatever, with sensitive data. We want to use, on the one hand, data that is close to production, but it should be desensitized, obviously. And yeah, that's a problem statement. So what's the idea? Yeah, we want to use reproduction data, but we want to anonymize sensitive data out of it. We want to add variety to it. And it's obviously required that we can scale that kind of load test setup, right, in order to saturate or even kill our destinations, because we want to know how much will it cost us, right, to run our later production setup. And we need to measure it somehow. That connects a bit to the talk I did to the UG last time about monitoring, right? So Cribl internal sources, logs, and metrics is quite useful to see throughput, to see error messages coming back from your destinations, etc. And yeah, we'll take a look at that at a later point. So what we will do today, I will demonstrate you how to capture some reproduction data using Cribl's capture capability. We will create a custom DataGen template out of it. We will anonymize some data out of it, right, by overwriting it, ending randomization, simple JavaScript syntax, right, to some field that we will call sensitive. I just took a simple example here. Then we'll add some variety, right, because we need to cover certain things, as you can imagine, and I did this in the Splunk user, in the B-Sites Splunk talk, metric store testing. If you just have one dimension, it's obviously a way better compression than it is if you have 5,000 hosts and thousands of different dimensions, etc. So we need to add some variety. Then we will scale some workers and worker processes to increase our data footprint that we are sending out to the destination. I've prepped, in fact, 3. We can choose basically what we want to look at. And we will take a look at the throughput and success by checking the monitoring console and the Cribl metrics and logs, which you obviously could send as well into the analytics tool of our choice. Hopefully not the same one we're load testing, because then we're shooting ourselves in the foot here. I think there are no questions on that. So it's demo time, and we will build an army of goats, as I called it. That's not too complicated. Let me end the presentation here. So that's our test setup. It is a Cribl 402 instance running in the cloud at the moment with exactly one worker. We will scale that out later. And what I've done so far is I've set up some destinations and sources, but that's it basically. I've not set up the DataGen itself yet, which we'll do now, which is quite easy to be done. So I have connected one source to that setup here already, which is hopefully being present here, which is called Splunk in TCP Splunk. That's where I'm sending it in. Let's capture roughly 100 events, and we see that this is a very simple data source, right? You can see, I mean, the one that are a bit familiar, that this is already a DataGen just running on a different instance. So I'm having a different instance here where I'm running a DataGen to generate some stuff. So if we take that now, usually we could save it as a sample and use it in our pipelines in order to basically simulate what the pipeline and the functions within the pipeline will do to the data. But there's a second button that is a bit overlooked most of the time by customers. We could create a DataGen file out of it. And as you already can see, that looks very familiar. If you have seen event breakers and stuff like this, these are already discrete events, but we have the same coloring like we have in event breakers. It already detected, hey, that looks like a timestamp. And it gives us that nice variable that says, okay, $timestamp, and then the pattern of the timestamp. And honestly, that looks absolutely correct to me. When we, you have seen the timestamp basically, right? So that's basically day, month, year, and then with colons, the time and the time zone at the end. And it has scanned it automatically. You could customize it if you need to with timestamp anchors and the right manual formats. There are some examples, but you can customize it fully. JavaScript, date and time variables work. You could add a time zone as well. Auto is absolutely fine for us. And we will simply save that now as a DataGen file. Now we have a new DataGen, which is now listed under DataGen, obviously created here at the latest. There are two ways now to use that file that we've just created, by just clicking Set Up DataGen or by moving via Data Sources. Where's DataGen? Here it is. And here's already one running because I needed to test connectivity, obviously. So we'll just replace that one here and add our manual DataGen file, which is called, that's the one. I will kill that out. And let's start with just one event per second because we want to play around first with that data a bit. We could already add fields here if we want to, right? Something like a source type, an index field, or whatever we require, right? But we don't have to. So I will just save that for a second. It is already connected, I should have shown that, to two destinations. As you can see, it has a pass-through pipeline right now. And it's connected at the moment to two different destinations. What we will do now is we will add a custom pipeline where we will add some variety and desensitization functions to it. And as you can already see, when I now commit that here, my default commit message is 3 dots. I could have configured that. We will see that the two destinations I've connected, I could use it as well, send it as well to Splunk. At the moment, it's just S3 and Confluent Kafka. That within a couple of seconds, you see here's the data coming in, right? That works. You see there's a certain amount of data coming in. I'm consuming it at the same time, by the way. And the same applies to S3 somewhere. If we look at Cribl UG, yeah, there's no index field, but the source type is access common. And we see here that we get some, I used the partitioning expression. Here's some objects in, right? So what can we do now with that data in a pipeline? We move to pipelines, create a new pipeline. We give it a nice name called Cribl UG. And we could now take a fresh capture because we have the DataGen, obviously, right? DataGen Cribl UG testing. Here we go. Let's take a capture. So here we go. A couple of is already sufficient for us because we just want to simulate what happens to our data set. Save. Here we go. So as you can see, there is already some kind of variety in because I saved within the capture different kinds of messages, but still that might not fit what I'm looking for, or I want to remove certain information, right? So for example, to start with, it could be anything, right? You could have credit card information, passwords, username, stuff that you want to get rid of. And in that example, I would just get rid of the IP address, right? Which is the easiest way, which is simply done by a mask function. Because I want to get rid of it. I want to exit out basically. So, and very nice is that we can work on that data sample here with the regex. Very simple. And by just opening it, we directly get the events that we want to process here. And we have a match regex and a replace expression. And then we can take a look what happens with that data. So we know, and I'm not the regex guru here, obviously, right? We can easily extract the first group, which is an IP address, and I would just keep it very simple, and people will hate me for it because I'm really not the regex guy. I can have up to, oh, come on. I can have up to 3 digits, right? A dot, and then I will just repeat that. And that's my first capture group. That is by far not efficient, obviously. Wait. That is.
I think you want 1-3 there.
Yeah, exactly. 1 up to 3. Good to have experts on the call, you know. So
I think you need a comma instead of a dash.
Yeah, I didn't get that.
A comma instead of a dash. So it's either 1 or
that's right.
3.
Yep. You're right. 1 comma dash 3.
Here we go. That's really interactive here, and I like that.
I probably could have typed it fine. Muscle memory would have worked.
Now we have the first match, right? And if we just want to get rid of that one, we could basically just build a second match group where we match the rest in, right? And then we could have a replace expression, which, right? We can reference G1, G2, etc., right? In order to build something. The docs are pretty straightforward about that as well. Let me open them. Mask, because there are very neat examples in. Do not try to find out everything on your own. Come on. Here we go. Right. Here's a typical syntax. We need to reference it by, it's a JavaScript thingy where we need to reference it by $, and then these brackets here in order to reuse the group. So if we want to exit out, right, we could simply do something like this here to put X in front, right, and then just reference the other group, which is this one. Is that right? Yeah.
Yeah.
$, there's $, missing. Here we go. And we want to reference, what did I do wrong? That should generally work. What did I do wrong? I'm not sure. Wait. Let's get rid of that one here first. Okay, that works. I need to concatenate it most likely, which most likely works.
Did you have a plus? There you go.
Yeah, here we go. Right, so that's the first step. You can imagine you can do anything with it. You could as well call the crypto functions, right, which is, wait, it's in the docs here. You could as well hash it, right, MD5, SHA, whatever, depending on what you want to achieve, right? Maybe you want to make it decryptable, etc. Feel free to use crypto, decode, encode, etc. That works. In my example, I just exit out and leave the rest as it is. First task done. Save that. And we will discover that we have just removed IP addresses because we might have in our data sample IP addresses of a real-world production setup, and obviously we should not use them. Right? I could have as well put in a fake IP address, or I could have randomized them. We come to randomization in a second. So now that's the first step. Then we said we want to add some variety to something, right? Which is not too complicated. I'm just cloning that for myself here a second because I'm not the biggest guru on that, but it's quite simple. For example, we could use an eval function to randomize a host, which is not too complicated. Give me a second. Yep. I have that somewhere already prepared. You just need to find it. Here we go. I will show that for a second. That's how I load tested the Splunk metric store. I randomized, sorry for the wording, the shit out of it. Right, so you use the code function to tag different metrics. And then I use the randomize group here, where you can see for all the different metrics, how I randomize different things, right? So in our example, I will just use that simple mass floor function with a two-string method, which is absolutely straightforward and simple, and Google is your friend absolutely on that. As well here, simulation or having an output prepared for it works, right? Actually, that's not a string, that's now, should have used that one here. That's now, yeah, that's even now with characters. And now we have a 7-digit, come on, host, no, a 4-digit host name in that case, or up to 7, right? I could have hard-coded that as 1 to 7 or 2 to 7 to really have a limit, but it's now up to 7 characters, which would give us theoretically up to 1 million different host names, right? Let's limit that to 4. And that's it basically. So now we have, no, wait, substring 4. I missed it somewhere. Yeah, so wait, the above one is basically the limit to 5,000 with a character with a digits, right? So that would be exactly 5,000 different nodes here, but just being digits. In the end, it doesn't matter, right? So now we have some variety on hosts that we could use, right, in order to load test our destination. We could apply the same to any kind of other field. We could have extracted other fields out of this here before with a parser function. I think Apache Common is even predefined in the parser function in order to have a certain amount of posts and puts and whatever we require. We could have randomized this here in the end, right? In order to have different response times, etc. But that's just an example, right? So you can customize and change and randomize any kind of field with any kind of information, as long as you are somehow familiar with JavaScript and most of the stuff. Stack Overflow is my friend, right? I've never learned JavaScript in my life. I'm coming from the good old Turbo Pascal days, right? C++, Turbo Pascal. It's not JavaScript for me. But still I can use it, right? Because I use Cribl on a daily basis. So now we have that ready, right? We have something removed and we have something that we randomize, and that's already sufficient of what we want to achieve here today. There's one thing which comes unfortunately out of another test that I did. I want to get rid of that field here, which is quite easy. So if you have extracted already something, right, you can always use the eval function to remove certain information. That's already my whole function. So if I now take that here, it's saved already, go back to my sources, go back to the DataGen source for the Cribl UG testing, where I have just simply used the quick connect. You can as well send it to routes, set the first route as non-final, send it to Confluent first, and then send it to S3 in my case. That's as well the same way, right? It doesn't matter. So we just change the pipeline here into, where is it? Cribl UG. Same here. Cribl UG. Save that stuff. Commit it. And now my single worker will produce one event at a time, obviously, right? Because that's not load testing it. That's all the prep work. You scale it later, right? So as that's done, we should be able to see that here. I, of course, have already connected the same to the sources. So if I go back to sources, Confluent Cloud, you see it's at the moment red, which is fine because it's restarting. Confluent Cloud is a good Kafka test system because it offers you something like $300 for testing budget and absolutely straightforward to be used. I think the budget doesn't even expire. So that's pretty neat. What have I done? Probably I am in the wrong. I was in the wrong Cribl environment. Here we go, right? So that's now what I get back from Confluent. And you can see that it already works, right? There's nothing spectacular about it, but you can see that raw is X'd out and my hosts are now varying a bit. And we can see the same here, just open that for monitoring purposes. So if we now want to see, I mean, maybe my boss asked me, hey, we have that new Confluent Kafka thingy. Can you tell me if it can sustain the load of 5,000 events per second? And my answer is, of course, yes. Of course I can. There are two options to that now. I could try to kill my single worker, right? By going into, by changing my DataGen to simply, and that's important when you click on here, events per worker node. So independent of how many processes you have, it tries to create now one event per worker node. Of course, that's dependent on how many worker processes you have, right? What you don't want to have, you don't want to kill your Cribl environment. You want to load test your destination. So in my case, it's quite simple, and I've demonstrated that last time. I have it somewhere here. I need some more workers, which is as well quite straightforward. We go for EC2. Let's use the same instance types. What I'm using here, it is a T3X large. No problem. Here we go. Let's say we want, I don't know, another 9. Let's make it really big. We want Cribl workers. And I'm free to use, and I said that last time in the last UG meeting as well, you're free to use x86 or ARM architecture. ARM is usually slightly cheaper and it's quite performant, I have to admit. So feel free to use as well. ARM works, and it's for the leader when you're bootstrapping, and I show that in a second. It doesn't matter if you're deploying x86 or ARM. They even work in a mixed environment. You might have just different outputs here, right? So we are using a T3A.X large 4 vCPUs. That's more than sufficient. Yeah, I want to log in generally. I have an existing security group, which is just my launch wizard group. I usually up that to 20 for some logs and stuff. And now I'm bootstrapping 9 workers very simply. And that's exactly the beauty of it. And I've explained that last time in the videos on YouTube. To bootstrap Edge, the same applies to bootstrapping workers. You basically just call your leader, the init URL, the init API for the installed worker, give it the group token, etc. And that's it. Absolutely straightforward. And within, I think, 30 to 60 seconds, we will have 9 additional workers. Here we go. If we move out of here into manage default.
Is this where I insert the evil laugh?
You can. That's a German evil laugh. So within a second, we will usually have a couple of more workers here. They're just launching. And then we have an army of goats with 4 cores each. Default is 2 cores they will use, right? One is reserved for the API process and one is reserved for the operating system, and that generally makes sense. So you're free to scale that out to your needs, right? Probably mimicking your later production setup, etc. Already 4, you see, right? So we are growing. They're all getting their configs, as you can see. And suddenly we have 10 workers, which is pretty neat. Going back here, 10 workers, yay. So when we now look at monitoring, we have not much throughput, as we can see. Give it a second. There's nothing really running. I mean, we could now check it for destinations. Here we go. So how much does our Confluent Cloud and our S3 get? That looks kind of similar, right? The total bytes is slightly different because of not compression, but how it's basically formatting JSON to be sent out and what needs to be added to the format in order to be compatible with a Kafka or just putting it into an object file. That's why that is slightly different, but the total events should be similar as I'm sending to both. And now we can scale that quite easily. And we can as well see when the destination is having problems, right? So to be frank, I know both limits. I've tested it ages ago. S3 has an API limit at some point. And the free Kafka of Confluent has as well, of course, a throughput limit. So you can break that at some point. I can't even recall the numbers. I think the API limit for S3 for bucket uploads is by default 1,500 or 3,500 API requests per second. That's quite some data. And it costs you a fortune to load test that. Be careful doing so. Not the EC2 instance is the expensive one. If you load test S3, it can become quite expensive at some point. Going back to manage to our default here. You've seen already like a small spike because instead of 1 worker, we now have obviously 10 workers, which means we have multiplied our traffic by 10, obviously, right? So if we go back to sources, DataGen, and this is now, you can combine multiple data generator files in the same here. The throughput limitation that I've seen, and it depends, of course, on the CPU clock speed of your machines, but I have been easily able to test with 10,000 events per worker node if it's just 2 worker processes enabled. So 5,000 is no problem. But let's see, let's get there slowly, right? So we test with 5,000. And as that's so easy, right? We can easily now add some stuff. And when you look at while it's just committing that, we take a quick look at S3, Amazon. Here we go. Wait, that's sources, destinations. S3, you see that I have applied the minimum config. So that's non-production optimal, just to be very clear, but I wanted to show quickly some data. The max file size uncompressed is just 5 max. The files just stay open for 10 seconds. And if there's no data to a certain file, it is as well just 10 seconds. The usual setup is you would make that a way bigger, right? Because you want to limit those API calls later, just to have that set. Going back to monitoring for a second, we should see a huge spike. Right, here we go. We see as well, our CPU load average is still fine. That gives you at least an indicator of, are your Cribl workers doing fine? Do not overload your Cribl workers. Add more than or add more cores, however you want to call it, right? In order to spread the load per worker node or across multiple worker nodes. So scale out versus scale up. And right now, let's limit that on a 1 minute basis here. We should see that we are doing, yeah, that sounds not too bad. 10,000, 15,000 is in, 18,000 is out. So we need to wait obviously for some time, but generally speaking, we're generating quite some data here, and we should be able to see that here. So we are just ingesting at the moment 25,000 events per second, which is not too bad. And obviously I can only hit a limit on the API of Confluent. I will not able to break them. And I didn't want to break my own Splunk environment today, which I did last time while I was doing metric store testing. And because for the ones that are familiar, there's a maximum indexing limit per indexer. Simple as that, right? As you can imagine. And for S3, the same would apply here. Let's take a look. So we are at the moment here. It needs to refresh. Wait. Index is now set. Now we have 5,000 hosts, hopefully, in random numbers. And we can see data for all of them. Let's just click in the first one. And we will be able to see our test data. It's all nicely gzipped. You see they're very, very small because I have limited them to 10 seconds of a lifetime. On the other hand, be very careful. The maximum limit of open files for S3 is 2,000. So having 5,000 hosts and having host as part of the partitioning expression will break that setup, right? You're in conflict here. So don't make host part of the partitioning expression if you're having more than 2000, because then it's stream, the worker process are basically opening and closing files all the time instead of giving them a certain growth here. And the data that we have in, I don't think if I've shown that in the user group at some point, but basically you could now use the replay function with a collector in order to retrieve the same data again, right? To see if that performs pretty well, or you just can take a look, right? Download it via the tool of choice, whatever. But we should have our data in here. Here we go. Wow, there was exactly one event in, right? I mean, honestly, that's production setups for some customers, unfortunately, right? So it is what it is. Sometimes you don't have that huge cardinality or something, right? Just what it is.
Right.
That still runs, yep. And we could now hit any limit, right? So I said we start with 5,000. I will use 2 more minutes and then we can move on. So when we go back here, wait, let's go to monitoring one more time, just quickly, put it to 5 minutes for a second. We see that we have quite a sustainable load here. No, we don't. We are already breaking something. You see that? So we have spiked here, right? Yeah. And we have already killed something, which we can now easily observe, not only with the monitoring console, but we could simply go into, come on, monitoring destinations works. You can as well go to data sources and destinations, right? So, for example, the S3, let's take a look at live, at logs. Yeah, that looks okay, that works. And it's still sending something out most likely. Hopefully every 10 seconds or something. No, obviously it's not sending out anything at the moment. Let's take a look at the status. Yeah, okay, that does it, interestingly. And the other one was, let's take a look at this here. This is as well live, but that's not. So that's just when it's starting. Successfully connected, okay. Might be that I'm simply, wait, this is just a first worker process. We would need to look at different worker processes here. It says it's running. Interesting that the charts say that it's dead.
It's dead, Jim.
It's dead, Jim. So whatever I killed, that was already too much, right? So we can simply now drill that down, or size that down again. Of course, load testing takes planning, takes documentation of what you're doing in smaller steps, right? I just basically turned the wheel, pushed the button in order to have a lot of load. But it's quite a simple approach in order to simulate data on the one hand, if it's just low volume, right? Or if you want to load test a certain destination. I said I did all the Splunk metrics or testing with it very successfully by creating up to, I think it was 1.2 million metric points per second, which was quite crazy. It was as well a bunch of 20 workers or something that have been used because I needed traffic, right? You can only prove that a destination is doing well, and my goal was compression testing in that case. So how well is Splunk Metric Store compressing here? That was absolutely awesome. Questions?
Sounds like fun.
Any questions on that generally?
Sounds like nothing right now. I didn't see anything in the chat.
Sounds good.
Although I've lost the chat.
In that case, I just have to add 2 more things. The first one is obviously join Slack community if you haven't yet, but I guess you do, otherwise you wouldn't be here. I think it's the most prominent distribution channel, and tell your friends. And speaking on your behalf, Rich, looking for speakers for the UG.
Absolutely, yeah. Thanks for mentioning that. I believe we have one for next time. So everybody has like a month and a half to 2 months to kind of prepare. Find some topic and let us know about it. Doesn't have to be complex, doesn't have to be wonderful. And in fact, We've actually done some where we've had little 15-minute pieces and just put 2 or 3 of them together. So, if you have something that's just going to take a few minutes, 15, let us know, because we can probably like find a session where you can do that with several other people. Lots of fun that way sometimes. In any case, up next is tech tips from Kyle. So how you don't have to open support tickets quite so often, hopefully.
Go, Kyle.
Yes. So tech tips. So some of these are probably just ease of use things that you may already know or may not know. And then a couple of these might prevent a support case or two. So the first one is any blue bar that you see as an input in stream is going to be JavaScript. So you've probably seen that throughout. Any green bar is actually regular expressions. So
yay for regular expressions. Oh, sorry, I'll mute myself now.
you're good. So that you can see that in like mask or reg extract here. Another thing too that some people don't know about is this advanced mode that you can pop out to get another view of your regular expressions. Let's get out of here. One thing that I actually didn't really know for quite a while was if you go to like your pipelines page, we have this little 3-column looking menu here, and you can select what columns you actually want to display. So if you want to keep it a little cleaner and just have description, or you can decide what you want to view. Another thing, something that was added in, I believe, 4.0 is our pipeline profiler. So if you have a sample set of data, this is just some random data that I grabbed before today. But if you click this little 3 dots on the right and do run with profiler, then when you click on the pipeline diagnostics, in addition to the statistics you always had, now we have the pipeline profile page that you can identify. This is useful for troubleshooting pipelines. If you have like less data throughput than you expect, you can do this pipeline profile. And instead of looking at it, originally it was a CPU profile that looked something like this. As soon as it'll load, that is a lot harder to read if you've ever looked at this. Yeah, of course, this takes for a little while to load, but the pipeline profiling for if you're updated to 4.0 is definitely very useful for identifying like problematic functions within a pipeline. It's just, it'll tell you the milliseconds it takes to complete each function. Let's see. So those are some, so keeping with a theme of JavaScript, for things like routes, right? The filter is JavaScript. You see the little blue bar. One thing that you might not have thought about is how efficient is my like filter in here, right? So I mean, true is not a very good example, but like when you're doing dot includes or dot test or which one's the best one, there is a blog that is written by Brendan Daup, and I can post this in the Slack or the Zoom channel here. But he went through and tested all of these and showed with data, right, which ones are better. So includes, I've seen a lot of improvement of just like taking a bunch of searches or tests and then replacing them with includes, right? For your filters, or, sometimes that'll also be in the pipeline filters. And so it can start to stack up. Another thing is just if you want good JavaScript documentation, Mozilla has great JavaScript documentation. So if you're new to JavaScript, I use this documentation all the time. I'll post that in the channel too. One more related to that might actually prevent some support tickets that actually came up from one of my coworkers is that make sure your process count. So like if I'm looking at group settings, let's say you have a worker that has 12 gigs of RAM and 7 worker processes. Our default memory is going to allocate 2 gigs RAM per worker process. So that's going to require 14 gigs of RAM more than the 12 or whatever you had, right? So just make sure that the memory setting for your worker process here doesn't go over the amount of RAM that you have on your workers. It's default 2 gigs. Let's see. The last one that I have, and I don't really have anything to show in here, but it's just our HA documentation. I believe it's in here, but is our recommendations for the NFS volume. So if you, let's see if I can find it. I should have pulled this one up. I think it's here. Yeah, here we go. So NFS, make sure that these things I've found have created some issues or support cases. So having IOPS less than 200 or the ping being greater than 50 milliseconds. So if you have anything less than that, you'll likely run into some like interesting performance issues that really like things will take too long and it'll really present itself in weird ways within stream. So if you're doing HA, make sure that your NFS has these baseline requirements. Okay, I think that's it.
Awesome.
All right. Well, that was wonderful. It sounded wonderful. Of course it sounded wonderful. No, that was useful. I knew about the little 3 pipe thing that did the fields. Well, I knew about it back in 2 point something and I totally forgotten about it. I'm glad you reminded me.
I probably learned about it then and then forgot too, but my friend coworker showed me it yesterday and I was like,
oh yeah, that. Right. Anyhow, I think first round of applause for everybody. Yay, thank you much. Yeah, they're all on mute.
I say,
Perfect.
when's the next meeting, Rich?
The next meeting will be the second Tuesday of next month, which I think is like the 14th or 13th or something, right?
Yeah, we get to do a
Valentine's
Valentine's
Day?
Day show.
It's the 14th, and it's going to be at the same time this meeting was. I put it off screen. This meeting was at the new and improved. Oliver, was this a little easier to get to and not have to like put the kids to bed and then wander off and go do things? And
I'm a night owl anyway, you know.
well, that's true. But anyway, yeah. So anyway, at the new time, which is 10 a.m. Pacific, noon in the one true time zone, US Central.
You mean GMT?
No. 1 o'clock Eastern, and I don't remember what it was in UTC. Is this 1600?
1800.
1800. Yeah, sorry. 1800. Yep. So anyway, see everybody next time. Bring your friends, because you know what? We'd have more swag.